Today I'm going to use Tencent Meeting to record my video. So let me have a look. Oh, right, that's not bad. So let's dive into the problems and study plan. It code 75 and got another question, right? Binary search. Let's see the second the second question about binary search. Given two positive integers arrays, spells and potions of length n and m respectively, where spells I represents the strength of the ith spell and potion j represents the strength of the j's portion. Does that mean? You are also given an integer success. A spell and a potion pair is considered successful if the product of their strengths is at least a success. Return an integer array pairs of length n, where pairs I is a number of portion that will form a successful pair with the ith spell. The number of portions. What's the portion?不要，但是 spells 是符咒。Let's say for example, spells is 5, 1, 3. Portions are 1, 2, 3, 4, 5. Success is 7. Output 4, 0, 3. It looks like the times, like choose one item in spells and times each items in portions, which get a 5, 10, 15, 20, 25. And 4 of them are larger than success. I see. So in my opinion, we should use two layers. The first layer, we might use a for loop to um, get the item one by one in the spells. And after that, after getting the spell, we can use the binary search to find which one is larger. Like I found the J one, the J's item is larger, but the J minus one is smaller. After that, I have to calculate how many items are larger and how many items are smaller. But there is another question. The portions is not the ascending order or descending order, is no order. Like in the example 2, portions are 8, 5, 8. How to save this question? We can use a sort. Firstly, if we use sort, it will get n o n log n, and after that we get on for the for loop in the first layer, and get the log n for second layer for the binary search. So times them together is still n log n. So I think the time complexity is n log n. And I think that's good to me. I think that's good. So firstly, we have to get the sorted array. Let's say const sorted portions. Yes, portions dot sort, right? The sort method, and let's give a function like a b as a parameter, and an arrow which include a minus b, right? We have to use like this. After that, it will goes the sorted array into the ascending order. Let's just console log. We don't make sure that we have the ascending order. So after console log, we can firstly return. Yes, of course we can firstly const a new array called answer. It is an empty array. After that, we will save all the answer use push or something else, and let's return this answer, right? So firstly, let's have a test. The test result shows that it's ascending order, so that's what we want, right? After that, we can use a for loop for let I from 0 to the n. N is spell dot length. and I plus plus. And in the for loop, the last one is push, right? And the first one is, get the items. So we write these two first. We can constant spell, right? In spells. Actually, we can use the of, let's say const, the spell of spells, because we don't need I. And in the final answer or the final line, we can only use push, right? Push will only cost 0.1, so it's not cost too much. So let's say answer push, and the final number, right? Let's say none. So this is a final sentence. So firstly, let's add a number. We see to let it remember how many items success. So let num is 0, and let's use a binary search, not the recursion, because recursion use on, but after we sorted, the binary search will only cost O log n, so it's cheaper. How to say a binary search? Firstly, we have to calculate the left and the right. After we find the actually pivot, we can return the pivot index and use this index to calculate how many items in this sorted portion arrays are a success. Okay, that's pretty good. So firstly, we use the times, but we have to use times m times, because we have to let spell time to all the items in the portions. That's cost too much. So we can firstly divide this spell using the success number. Firstly, we have to check the success number. Not the success number, but the spells is not 0. Yes, spells I and portion I is all greater or equal to 1. And the success number is also greater or equal to 1. So that works for me. So right now we can firstly add two numbers called left and right. So left is 0 and right is m. So m is portions dot length minus 1. That's the left and right. And let's dive into a while loop. So in this while loop, we have to make sure that left is less or equal to right. So after that, we have to first calculate where is the pivot index. So const the pivot index, or we can use the not pivot, because it's not the right a clear line. we can use a mid, right? Mid index, calculate them, or we can use middle, because left and right are all index. That's a lot of thoughts. Never mind. Because middle is firstly we have to add left and choose the middle part in the left and right, and add the left and the middle part, the middle index in the left and right, add them two together, which can return us the right now middle index. Where is the middle index right now? So we have to use mass floor because we need an integer. And inside of this floor, let's use right minus left plus 1 and divide it by 2. And that's what we actually want. So after that, we got the middle index. Let's check if this one is good. So firstly, we have to also calculate like the new success, right? The success divided by spells, the spell. So let's say the new success, okay, is CC size divided by spell. So we calculate that, and in this while loop, we only use new success to have a look which one is bigger, which one is smaller. So we firstly got the middle index, and after that we can get which one is the middle index. So the middle number, right? Mid num is the in the sorted portions, the index is mid. After that, we have to check if the this one is equals to the new success. Yes, is equal to success, but it's truly hardly to reach that. Because it's not, it have steps between each items, like so how about less than or equal or greater than these two? Let's divide by these two. If the mid number is less than the new success, so that's not reach that point. And if it's greater or equal to that new success, it will be successful, right? Let's say it's at least success. Yes. Am I right? At least a success. Yes, I am right. So less than is not at least, and a greater or equal to greater than or equal to, which means at least. Only two divided part. So we have to calculate like that. Finally, we only get left and right. These two part. And or we can use mid, because when the left is equal to right, the range only have one items. So this is the last one, and we have to figure out if this is successful or not. So yes, we can write this quickly. So first one, we need mid num less than new success. As this in this condition, the right, not the right, let's say, the mid num is less than new success, means that in the left and the right, the mid one and the success is larger, so we have to find this success one into the middle and the right. So let's use left is the new the mid, right? Yes, else, which means yes, it works. We can use left is I remember it's mid at 1. And if the mid num is greater or equal to, so that success to the right one, the right index is mid, not mid minus 1, because we have a equal to in this condition. Well, actually, this would work if we only use like the mid num is equal to new success and break. That would not work because we might have many items which are all success in this equal to part. So we still have to find the last one, right? So we can use right here, because in some part it will goes into this one. The left is only, equal to the right. So in this condition, we have to treat it as a boundary condition. If so, why not use this one, the left smaller than right. If we use left smaller than right, then the mid one is, I think, is the left. Let's say right is left plus 1, so right minus left is 1. At 1 is 2 divided by 2 is 1, and left and 1 is right. And that the right is mid in this last sentence means it goes into mm, a deeper in a deeper loop. Oh, I don't know how to fix that. Let me think about this for a second. Hmm. Is mid. Right is mid. Actually, in the traditional binary search, this would use right is mid minus 1, so it won't have a lot of boundary problems. Okay, so in the last part, we can use another conditions to um, operate this boundary conditions. So if uh, no, this not be successful, we can only use this here and add else in front of this if else and if to say it's they are the same. So in this condition, uh, we can have a lot of very not very a lot of complex large like if the midterm is new success, we have to check to find the beginning one, the first successful one, right? Yes, I think that's right. Yes, so we can use the while. Mm, while while loop. First, we have to add a let the first one, the first is right now mid, and while the what do we call it? Sorted portions. While sorted portions first is still success, right? So how to get this success? Right now, the mid num is equal to the new success. So the sorted portions first must be equal to new success. Well, in this loop, we can let the first double minus to find the last part. And after that, let's get a break, right? But before the break, we have to throw out which one is or the right now which index is the first successful index. So we can add another let outside this while loop. Let's call it uh, the first success index. Yes, let's say -1. And in this part, we have to change this first success index into the first add 1, because right now first is not success, right? It goes out of the while loop. And yes, this is the last one. And we have also have a boundary condition in the beginning of the while loop. If the left is equal to right, what should we do? Mm, Actually, what if we use the left is smaller than right as the condition, as a while condition? In the last while loop, we can say that the left is right -1, because if it's the left is right -2, then we got this right minus left is 2, add 1 is 3, divided by 2, 1.5, and mass dot floor is 1. Left add 1 is not left and not right. So the final condition is left and right. The left is right -1. But in this condition, let's think about that. We have to still check if the division is between left minus 1 and left, or is between right and right plus 1. Because let's say if in example every items in the portions are all successful, so the division is between left minus 1 and left is between minus 1 and 0. So right, this is the thing we want to focus on. So we can use this, still use this, left is smaller or equal to right. And in this condition, if left is left equals to right, so we have to calculate all of them. So we firstly calculate the left minus 1's number. If we have to focus on the boundary condition, if f is greater or equal to 0, right? And let's see right now. We can say that the left is 0, right? Or the left is n minus 1. So right, the left is 0. So we check about if the division is between left and right, or between left minus 1 and the left. So we have to figure out left number is successful or not. So sorted portions left or just 0. We can use left. This is successful or not. So how to say successful? This is not successful, right? We can use this. Is less than new success. Yes, right here. Less than new success. So it's not successful. We can say that the division is between left and right. Not between left and right, because they are the same. It means it's between left and left plus 1. So what do we use for the first success index? It must be left and 1. And else, like this. first successful index to the left. Okay, this is the first condition, and the second condition is left is equal to n minus 1. How to say n minus 1? The portions dot length minus 1. Oh, it's m minus 1, not n. So in this condition, if it's not successful, oh, it's not successful means all of these items are not successful, right? So the first successful index goes to the left at 1. Left is right, so we can use left. Yes, left at 1. It's not. Use left. And the third condition is this one inside of the item. But actually, I figure it out. We should use this boundary conditions outside for this if sentence, like in the last part, because this step we only need to calculate the first successful index. Yes, this is my fault. We no need to use this. Oh, we only need to use these two sentences. And after that break, right? Yes, if left is right, then can break here. And we already get the first successful index. And we have to calculate how many items are successful. So we got the number m as portions.length. So there are m numbers here, right here. And the first successful index is from 0 to m. So we can directly use here. It's not an m, but it's not a num. We can use portion.length as m minus the first index, successful index. And the result will be from m, from 0 to m. Yes. So we can delete this one. I think that's all. Let's have a look about this. No, why this is wrong? Output this is 6. No, we shouldn't have 6 because we only have 5 items. Oh, 6 means the first successful index is still -1. That's weird. Oh, that's truly weird. Successful index. This is the Greek part, and this is not, but we can put these three sentences outside of this value and only change this y into smaller than, not smaller or equal to. And delete this break. This should be right. Yes, there must be some conditions I do not check. Kind of conditions I don't think clearly. Oh, we still have wrong answers. Why? Let's have a look. Output is 6, but expected is 4. Oh, that's truly weird. Hmm. We add test cases here, and let's have a look about. Firstly, this would be no problem right here, right? So, sorted portions. And what should we check next? Is 6 is truly weird because uh, we have not the 7, but one is 38 and another one is 30. 30, 50, 5, let's say 5, 10 minus 30 is what we need to know. And the comparison we need to know. So console log the new success. We can console log new success here. Yes, here. And also add the first index. First successful index. First we can check 1, 7, 7, 70, 90, 24, 26, right? And the new success is this one. We had to check the last one. 70. So, oh yes, that's 70. That's right. And 1, the first successful index is 1. So 17 is not 1, right? It's 3. Why this is 1? It's truly weird. Mm, something wrong might be here. We got something wrong. Here, it should be here because 17 and 70, that's the same. They're the same. And let first is mid, while mm, so that first. Yes, this should be the final block. Mhm. It's the final block. Ah, yes, we got them. 3, 2. Oh, right. This already calculated the correct first index. So outside of the while loop, we shouldn't calculate it again. So if this one is not -1, right? Uh, oh, if this one is -1, we have to calculate. After that, we don't need to calculate all of this. Okay, that's all. But well, that's actually weird. I don't know if I can make it more beautiful. Time limited. Exceeded. Why? Oh, because we use sort and we use does a lot of things. Really crazy. How to save this question? Let's say use test case here and just delete this sentence. I want to know if this is a problem of the sort. Actually, it's not, I think. Std out. Oh yes, we need to delete this console log. It will take a lot of time. And I don't think there is a So there must be a cheaper algorithm. There must be a cheaper algorithm, and I don't know. Maybe we have to ask AI. Uh, okay, let's think about that in 5 minutes because mm, it's reached out the limit. So actually, I got another idea. We can remember the spells. The answer of each spells item. We can reuse that. You see that in this time limit exceeded. We can reuse that. Hmm. Let's start another video. So this is the second video, and there are some problems in my recording recording tools. It only recorded my audio, not recorded my video, so I only have an audio part for with an image. Yes. So this is another try. If this is not work, we have to go into our old tools. So firstly, let's add a map to save those informations. Say if it's work or not. Add a map. Oh, new map. And every time before we push, we need to add that in the map. So map dot set. First one is the spell. The second one is uh, the final answer, right? Yes, we are correct. And it is 4, right? If every time we find there is a recording in the map, if map dot has uh, it has spell as a key, so we will use this one. Excuse. Answer dot push what? Push map dot get spell. After that we break. We continue. See if this works. Might be work for this test case, but we still have another 2 test case. I don't know. Let's have a look. Yes, accepted. So all of these three test cases are sort of that, right? It might give me some hints at the very beginning when we read this uh, question. Let's say constraints. So n is less than 10, 5, or what's this? It's 10 to the 5. Yeah, that's got it. 10 to the 5. 10 to the 5, is that right? And the spells is also, yeah, 10 to the 5. Actually, we can use a test cases as an ascending order, and the step for each item between each item is 1, from the 1 to the 10 to the 5th. 10 to the 5th, it will goes to the time limit exceeded, I think. So let's ask AI to have a look. Let it to give me some better idea. Should not use this one. So at the traditional thought, we find this item. This is not divided these two parts into different, in I don't know how to say. Let's have a look. Oh, firstly, yeah, we don't need a new array, and it also add a map. Map have spell, so it use a lot of times calculation. Hmm. Oh, that's too easy. So, so there are only two parts, successful and not successful, in this question. So every time we dive into the successful condition, we have to change the first successful index immediately until the left is greater than right. Oh, that's good. Why do I have a lot of strange thoughts about this? Mm, mm. Yes, let's have a deep thought. Yes, we need to remember this. To, how to say, detach the answer finding and the range smaller, getting smaller and smaller. See you guys.